In example 4, we're given the derivative of f is f prime co-squared x over x minus 1 over 5. So the derivative function is the one we need to draw on the graphing calculator. So go ahead and draw that, and you should get a graph that looks like this. So the question says, how many critical values does f have on the open interval from 0 to 10? Okay, so we're not going to include 0, and so we don't need to worry about the asymptote at 0, but we need to consider where the graph crosses the x-axis. So the graph's going to cross the x-axis here, here, here. Okay, so we have 3 points where it crosses the x-axis. Those are critical points that we have to consider. Now, we also need to consider if there are asymptotes. Okay, in this case, the asymptote is not part of that interval because the asymptote happens at 0. We also need to consider points of discontinuity. In this case here, there are no points of discontinuity that we have. So we can say that these are the only 3 critical points for this particular graph of f of x. In example 5, this is star next to it because it's a little bit tricky, but it says g is a differentiable function where g of x is always less than 0 or negative. And this is for all real numbers of x. And it gives us the derivative of f as x squared minus 4 times g of x, which we don't know, but what we do know about it is it's less than 0. Okay, it's negative. So I'm just going to express my f of x slightly differently. I'm going to just say that my f prime of x, I'm going to express it in its factored form. So x minus 2, x plus 2 times some g of x. And since that g of x is always negative, I'm just going to write that as negative. And the reason why I do that is because we want to know where the relative min and max are. This is what the questions are asking about. So if you take a look at the answers for A, B, C, D, and E, it's talking about relative min and max. So we want to know where we have zeros and where the slopes are positive and negative. So in this case here, we know we have zeros for x minus 2 and x plus 2. So that's going to generate some zeros. Okay, so I'm going to put that on my graph here, on my slope chart. And to find relative min and max, I just need to make my slope chart. So when x is less than negative 2, so I'm just going to shade this region. So this region here, x is less than negative 2. What that is going to mean is that this factor is going to be negative. If less than negative 2 is going to be x minus negative 2. A number smaller than negative 2 plus 2 is still going to be negative. And then we have the g of x factor, which is negative. I know that the slope in that section is going to be a negative slope. So we know it's sloping down. We have a 0 slope here. And then we just need to test some other regions. So looking at this region in here, I'm going to choose a different color here. Looking at this region in here, we can just choose some number and test the slopes. So if it's bigger than negative 2, we know that the first factor is going to be positive. Okay, so between negative 2, it's going to be negative because it's going to be less than positive 2 and bigger than negative 2. So since it's less than positive 2, it's still going to be some number like 1 minus 2. So that's going to be a negative factor. If it's between negative 2 and 2, some number plus 2 is going to be positive. So again, we can just test the point x is 1. And then we know that g of x factor is always negative. Well, if that's the case, we can see that from our slope chart, from our sign analysis, that's going to be negative times positive times negative. Well, that's a positive. that means it's going to be sloping up in that region, which means that we have a min point at x equals -2. And then we're going to test the last region here. I guess I'm running out of colors here, so we'll do this with red. And numbers in here could be, for example, 3. We can test the number 3. So when I plug in a number into the first bracket, I get a positive. In the second bracket, I get a positive. And then my third bracket was our g of x, which is negative. So I get positive times negative. Well, that means I have negative here, which means that's a negative slope. So there's my 0 slope in here. So that indicates I have a maximum value at x equals 2. So then we can see which one works for this. So relative max at -2, min at +2. Well, that's not true. Okay, min at -2, max at 2. Well, that seems to be true. We'll just check the other ones. Min at -2 and 2, not true, because this is a min and a max. Max at both, no, again, that's not true. And since we can determine it's B, we're not going to select E, so the answer is B. And this is based on doing some sign analysis, factoring that x squared minus 4, and then although we don't know what g of x is, we just treat that as a negative factor, and we can just do sign analysis to fill out our slope chart. In example 6, it says graph of a differentiable function f is shown as is shown. So this is our graph of f, and we want to know something about the function h. So h starts at 0, 0. So at x is 0, our h value is 0, and the h function is defined as the area under the curve of f. So it asks which of the following is true. Okay, so we're being asked about h at 6, h prime at 6, and h double prime at 6. Okay, so what we can say is that when we take a look at the h graph, the graph of, the f graph, that is the derivative. So f is the derivative, so f of x is telling us something about the derivative of h. Okay, so the y value of the f is the derivative of h prime. So that tells us then that h prime at 6 is equal to 0. So that's key. Okay, so that's about the derivative. We want to know something about the second derivative. Well, the second derivative, to interpret the second derivative from the derivative, well, we can tell what the sign of the second derivative based on the direction of slope. So through x equals 6, the slope is positive. Okay, well, what that means then is that the second derivative at x is 6 is going to be a positive value. Okay, so again, that's some key information here. We also want to know something about the y value at 6. Well, the y value at 6 is going to be to do with the area under that curve. And we can see that the area under that curve from 0 to 6 is going to be negative. So we know that the h value at 6, since it's an accumulation function, it's negative. So now we have at least a sign of the value of h of 6. What that means then is we know that h of 6 is negative, so it's got to be smaller than 0, which is h prime of 6. That's equal to 0, and we know that 0 is less than a positive value, which is h double prime of 6. So in this case here, we can see that the answer is going to be A, because we go from negative to positive values here. And then we can just double check the other ones, but we can see that none of them will satisfy this condition of negative 0 to positive.